So now, let us move on to the next part of our lesson. Remember, on our Discover Activity 2.1, you are challenged with a problem solved famously by Carl Friedrich Gauss. The said problem is an example of an arithmetic series. Take note that on the question, what is the sum of the numbers from 1 to 100? The numbers represent the terms of an arithmetic sequence with a common difference of 1. For the second part of our lesson, we will determine how did he come up with the right answer in just a matter of seconds. Let us start with the definition of arithmetic series. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. It is defined only if the given arithmetic sequence is also a finite sequence. It is represented by S sub n, which is equal to the sum of the first term, the second term, the third term, up to the last term. Taking the definition, let us try to solve for this problem. What is the sum of the terms of the arithmetic sequence 4, 7, 10, 13, 16, 19? Given on the problem are the first 6 terms of the sequence 4, 7, 10, 13, 16, and 19. And we are to solve for the indicated sum of those terms, which is represented by S sub 6. To start with, the definition states that the arithmetic series are the sum of the first term, second term, third term, up to the last term. So for this problem, we will have S sub 6 is equal to the sum of the first term, second term, third term, fourth term, fifth term, up to the sixth term. And by substitution, we have S sub 6 is equal to 4 plus 7 plus 10 plus 13 plus 16 plus 19. And by adding, we will have S sub 6 is equal to 69. It is easy for us to solve for the sum of the terms because we only have 6 terms. But if we are going to use the definition regarding the problem solved by Friedrich Gauss, it will not be practical for us to solve for the sum of the first 100 numbers. So therefore, we will have another method in solving that problem. Take note of these two formulas. To solve for the indicated sum of the terms of an arithmetic sequence, we may use either S sub n is equal to n times the quantity of the first term plus the last term all over 2, or S sub n is equal to n over 2 multiplied by twice the first term plus the quantity of n minus 1 times d. The choice of formula depends on the given problem. Let's go back on the previous problem and determine which formula is appropriate to use. Given on the problem, we have 6 terms. Also, we have the first term and the last term. We can also deduce the value of the common difference. Since all those values are given, which do you think will be easier to use, the first or the second formula? If your answer is the first term, you've got it right. It's easier because we have the first term and the last term given on the problem. To solve for the unknown on the problem, let us start first with the formula. S sub n is equal to n times the quantity of the sum of the first term and the last term all over 2. Substituting the given, we have S sub 6 is equal to 6 times the quantity of 4 plus 19 all over 2. We can divide 6 by 2, so therefore, we have S sub 6 is equal to 3 times the quantity of 4 plus 19, which will give us S sub 6 is equal to 3 times 23. So therefore, our answer is the same from the previous solution, which is S sub 6 is equal to 69. So the question now is, when are we going to use the second formula? To answer your question, let us have this problem. A pile of soft drink bottle cups has 1 cup on the first layer, 2 cups on the next layer, 3 on the next layer, and so on. How many cups are there in the pile if it contains 26 layers? From the problem, we can deduce that the terms of the arithmetic sequence is defined by the number of bottle caps in each layer, while the number of terms on the sequence is represented by the number of layers on the pile. With this, we can now have the given on the problem, which are the first term, 1, the number of terms, 26, and the common difference, which is 1. Since the problem is asking how many cups are there in the pile if it contains 26 layers, therefore, we are to solve for S sub 26. Since the last term is not really defined on the problem, we will be using the second formula. The formula we have S sub n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times d. Substituting all the given, we will have S sub 26 is equal to 26 over 2 times the quantity of 2 times 1 plus 26 minus 1 multiplied by 1. Simplifying first 26 over 2 and those values inside the grouping symbol, we will have S sub 26 is equal to 13 times the quantity of 2 plus 25 times 1. Which will give us S sub 26 is equal to 13 times the quantity of 2 plus 25. Simplifying further, we will have S sub 26 is equal to 13 times 27. And finally, we will have the value of S sub 26, which will be equal to 351. That concludes our discussion regarding arithmetic series. I'm hoping that you've learned a lot regarding the second lesson. Good day again, G10, and God bless. See you on our synchronous session.